Well, hi, good morning, and thank you so much for joining me in my shop here today. It is November 3rd already. It's already the 3rd? What happened to the 2nd? I don't remember the 2nd. Oh, well. So, interesting stuff with this radio. Discovered late in the game yesterday. I'm going to put these things together. One is there was a different kind of output tube in here from the correct one. The schematic calls for a 50 L6, that's a 50 volt tube, and instead there was a 35 L6 in here, a 35 volt tube. I wondered at the time if somebody had done anything to it, to the radio, to accommodate this different voltage. That's quite a difference. The putting a 35 in here instead of a 50, and I'm assuming they take the same current. All these tubes are using the same current in their filaments. It's the same current flowing through all of them. The result of that would be a higher voltage drop on every tube, including the 35 L6, than intended. Maybe somebody compensated by removing the light bulb and a light bulb resistor from the circuit. So we saw on the schematic there's a resistor, and across it is the light bulb. And these things are going to consume some voltage from the string. Perhaps the guy put a lower voltage tube in here and then shorted out the resistor light bulb combination, which is why there was no light bulb in here. It's not just a burned out light. The light was missing from here. And when I put a bulb in, nothing happened. Could be other reasons for that, of course. But it starts putting those things together. It starts telling a bit of a story. Could be malarkey, but it might be worth looking into. Just where is this resistor that the light bulb is hooked up across? This should be easy to find, actually, because the light bulb wires head down into the radio here. Let me get rid of this cabinet. The wires from the light, they go straight through a hole. Should be able to chase them down underneath. Coming through right up in here. Yeah. Well, I'm going to take a little more effort to figure that out. A little more. The other thing I wanted to do, and I ran out of time yesterday, was go after the capacitor that's supposedly protecting the output tube grid. And what we discovered about that was the triode that's just ahead of the output tube is running with a very low plate voltage, supposedly low plate voltage, only 35 volts, which is, I think that's the lowest I've ever seen. Okay, let's figure out this light bulb first. We'll figure that part out. Okay, let's take a look at the schematic here and some part and a layout diagram. Should be able to figure this out pretty quick. So here's the light bulb. Here it is connected across this resistor. This resistor's part number is 46, and it shares it with this. So what goes through my mind right away is that this is a continuous resistor with a tap in the middle, the kind that they stick on the side of a radio, on the radio's chassis apron, you know, like in this area. If we look at the parts here, look at 46 filament resistor, 4080 ohms. If we look here, we see part 46 pointing right here. There it is. So that's the resistor. The light bulb wires should be coming up to here and to here, or maybe over to this one, but I think it's these two. We should find them coming up there. And or somebody's done something. Let's go take a look at the radio and see what the story is. I've already taken a look at this, by the way, because the wires are so hard to trace. It took me quite a while. I didn't want to spend that time on camera. Okay, boost the light in here a little bit. So here is the story. Let me just grab my pointer. So the light bulb wires come up through a hole here, and really tough to follow them through this schmozzle under the radio here. There's no hope on the camera for you to see it. But one of those two light bulb wires shows up here attached to this terminal, which is attached directly to the power line. So that would make this the terminal to which the other light wire should be attached, and then this would be the voltage drop. Yeah, that the wire would be that the light would be utilizing. So, but it's a different kind of wire here. It's not the right type. That's tied on here is a capacitor and one wire going down. If we trace that wire, which took quite a long time, through the schmozzle, it ends up at a terminal down here, and tracing very carefully the other wire from the light, it also ends up at the same terminal. So that's what they've done. Rather than bring both light wires up here, only one wire comes up here, and the other one finds a terminal here, which is connected by a wire back up here anyway. So the light is connected. This resistor has to be working because the power for the light filaments is going through it. If this were open, nothing would work. But the light didn't come on. So it looks like nobody's done anything to the radio. It looks like probably what somebody did was they just put a 35 L6 in place of a 50 L6, and they may know from experience they can get away with it. Could have been done in a shop 40 years ago. I don't know. Who knows? So we're going to measure the resistance of that resistor up there, which is supposed to be very low. We'll see what it is. I think this is a wire wound resistor, so there's a good chance it's going to be correct. Jumping numbers. Shame on me. I left it plugged in. Not that it matters. The plug is dead, but safety procedure. Wait a minute. How did that happen? I had it plugged in. Had it plugged into nothing. Well, I don't know why it was jumping around before, but it's not. What's it doing here? Well, I don't know. 5 ohms? It's supposed to be 40 and 80. How about over here? Five all the way. Isn't it 40 and 80? I mean, this thing's in the circuit, so that's 80. It's got to be 45. Is that because of the light bulb that got stuck in there? Let me take the light bulb out. Light bulb's out. Well, light bulb's like a 5 ohm light bulb. What did I put in there? I put in there a 51. Try that again. I put in a burned out light bulb? No, can't be the case. Well, it can't be, 10,000 ohms. This is like a new out of the box. How's this happen? There's an interesting defect in the glass bulb itself. But here, we'll take a look on the little camera here. afraid the focus is not going to help us on this. Okay, bear with me just a moment here. And what I'm doing is I'm just going to turn off the autofocus and max this right up. Okay, let's take a look now. Looks pretty intact to me. And then on the other side are some defects in the glass. Like a string of air bubbles. Cool, never seen that before. So if the bulb's defective, it's because of a contact problem in the bulb body. I guess. Oh, it does look burned. It does look separated right there. I'm sure you can see it. If you see, the filament has a separation in it. Huh. Well, let's look at this other one while I got the close-up. This is the one that appears to have swallowed too much air. The filament looks... Look at the glass bulb on this one. Oh, it's broken right there. That's the spot where the air went in. And it looks like the filament has been corroded. This one also, it looks burned in two. Where did I get these lights from? I thought these were brand new. Well, I don't know what to make of that. So, that's not quite the right light bulb anyway. That light bulb is a little bit of a lower resistance than the 47 that was supposed to go in there. Let's read the resistance. I did read it. I did read it, and it was correct when the bulb was out. Yeah. Yeah, it's correct. So we have the option to put a bulb in. Except I don't have a bulb, so we don't have an option to put a bulb in. I could put another 51 in, but for now I'm going to leave it. We're probably going to end up trying to measure some of these filament voltages just to see how things are going. Okay, maybe we'll just move on from that stuff. I'm just noticing all the like this wire on the back of the switch. The insulation is cracked off here. Probably ready to crack off all over the place inside this radio. You know, and that's carrying the line voltage. Oh my gosh. I just looked up at the camera. Okay. Okay, I forgot to change cameras there. So I was just noticing that this wire here, which is part of the, like this is right on the switch, the power switch, the insulation is cracked off right here. It's bare copper sticking here. So, you know, if that's happening here on this wire, it's probably happening elsewhere on the same wire. And this guy's got line voltage on it. Actually, you know what? This is the terminal that's tied. No, I don't know. I don't know that. I won't say that. Okay. Back to the capacitor. That's the grid blocking capacitor. Let's take a look at that. Okay, grid blocking capacitor is this one right here, number 32. So we want to find 32. Let's just check in their parts list. 32. Condenser 0.01. And down here it's going to point it out. Whoops. 32. 32. There's 32 right there. 32 right here. They show it under this one and above this. Okay, so straight up and down this way. The only one like it except for this one. Straight up and down. Okay. Straight up and down by the volume. Straight up and down is this way. Oh. No way. No way. I covered my mouth. I don't normally cover my mouth when I see things. Okay, look at this. Where are you, little capacitor? There he is, way down there. Way down on the bottom there. It's out of focus, but that's it. And it's buried under everything. Here's the tail end of it. It's not going to be in focus down there. Right down on the chassis. Oh my gosh, look at this thing. Here. Oh my. Oh my. So, because I want to do this one first before doing any others, I don't really have an opportunity to clear the area out. I can't clear it out anyway. It's all wires. It's just all wires in here. That's the capacitor. Okay, you know what I'm going to do? I'm going to go and drink some coffee before I try and deal with that. We have some measurements to make too, electrical measurements to make first. Okay, if we take a quick look at the schematic here for the capacitor in question, it's this guy. You see one connection is made straight to the grid of the output tube and the other connection straight to the plate. When I look in the radio, and I'll show you this in a moment, I can see this connection is right on the tube socket terminal, and likewise on this side. This means I can probably cut away this capacitor, leave it where it is, put a new capacitor in some other physically different position, and connect them up pretty easily, terminal to terminal. Very good. Also puts us in a position now to make a test. That's not me making all that noise, that's two little kittens climbing around here. Troublemakers, where'd they go? Oh, they're on their way. Not enough trouble here for them. Okay, so we're going to make a measurement now. I'm going to measure the voltage on this side, see if it is 35, and on this side where it should measure 0 relative to the B minus, relative to this line here, bottom of these capacitors. Okay, let's do that. Here's what's going on. There he went. Okay, that's what's going on. Not much going on out there. Oh. There's one of them. Where's the other one? Oh! And they're gone. Okay. That's what's happening in this house. You can't be in here with these kittens and not be smiling. It's really a powerful effect. Okay, well, I was going to show you the terminals. Okay, so terminals, right. Distracted by the cats. There's the capacitor. That's the terminal it's connected to. That's terminal number 5 on the output tube, and that matches the my tube manual. The other end is, here's the other end is here, you probably can't see it, and it's connected to this terminal. So I can just go terminal to terminal. The thing is, they've laid this capacitor right up against the chassis. Did they do that on purpose? They wanted that capacitor up against the chassis for some reason? For noise purposes? I don't know, but I'm going to put one in. We've got to make measurements. Make measurements. Right. Distractions. Okay, so the voltmeter you see here is the one we're going to use to do this test. And just adjusting the 0 slightly. I'm practicing the sets. Ooh, what happened there? Somebody bit somebody. I'm guessing you could hear the holler from the cat, from the kitten rather. Okay, so practicing. So it's this terminal, this is the grid terminal, and this is the plate terminal here. So here we should see 35 volts, and here we should see nothing. but I suspect we're going to see something, especially if I lift my elbow so you can see the meter. Okay, ready to go. Just hesitating here. Okay, I'm going to put that on. There's no antenna connected, it's not important. We have powered it up. No light bulb in there. And we want this to be running with the correct supply voltage. 109 is just a wee bit low. Okay, 114 volts. Good. Is the radio making some sound yet? Yes, it is. Humming. Okay, so we're going to go on the plate side of that capacitor. And we should see on the meter's on the 50 volt scale, so it should come up to here. This is 35 here. Right over. That was over 50 volts. Really? Wow. It's supposed to be 35, it's over 50? How? Try again. So that's on the 150 scale, that's 50 volts. Whoa, 50 volts instead of 30. Could be a resistor problem. Okay, now we'll go on the other side of the capacitor. We should see 0. So I'm going to set this to 15 volts full scale. And we should see a 0 when I do this right here. So you can see a slight rise. This is 1.5 volts now, full scale. 1.5. Now, what's happening is the meter is drawing off some of the charge here. Pretty sure. Well, I can't be sure of that actually. So on this we're getting, you know, well, what is that? That's like a little over half a volt. It's not very much. 50 volts, so I wasn't expecting the 50 volts. It's not really a problem. Is it a problem if the plate voltage is 50 instead of 35? Probably not, really. But why would it be like that? So I'm finding the voltage here to be 50 volts instead of 35, and you know, that's the only thing that can really affect it, that this resistor. But if this resistor goes high, this voltage goes low. How do you get a higher voltage here? You get a higher voltage right from the start. Listen to those cats. They're just going crazy out there. It's supposed to be 100 volts at the top of these. Top of the bigger capacitors. Let's see what the voltage is here. That's kind of a curious arrangement here with this 10. Never really noticed. You guys are right in here now. And they're gone. Yeah, let's look at the voltage here. Let us look upon the voltage. Should be 100, so I'll put it 150 volts. And we're talking about these capacitors here. I did this before, didn't I? So that's 110. That's 90. So this 110 should be the 100. Don't think I'm going to sweat over it right now. The plate voltage. The capacitor leak is pretty minor, but it's enough to upset things, I'm sure. Okay, I'm going to put in the new capacitor there. Okay, got the new capacitor soldered in there, and look what happened. Look at this. Look at the floor. Oh my gosh, that's all shrink tubing. Oh no, those darn cats. Actually, it was me. It was me. I knocked that down. But I'm going to blame it on the cats anyway. Okay, what we want to do is operate the radio. Here it tuned something in, so I've got to connect it to an antenna this time. And so we know for sure it's working, and measure the voltage here. See if it's still showing up on the meter. When we get around to that, okay. Let's make it happen. Here we go. Can you see them back there? They're just out of sight. And now they stop. Of course. It takes quite a while for the radio to warm up, but I had the dim bulbs in the circuit, so that probably slowed them. Still got that crummy hum. Okay. So we haven't gotten rid of that yet. Let's just make sure everything's working here. Oh. It's not good. Well, that's just turn it up, Jim. Okay, so it's working even though it's got lots of problems still. So I did turn the volume way up. There, sit there. This. Okay, we're ready now for the voltage test. So we're on the DC positive, 1.5 volts. Let's see, did this make any difference? So let me just zero adjust the meter. Okay, so when I make contact, watch the meter. Last time it went up about here. Something like that. This time it's going up, but ever so slightly, like about a needle width or two needle widths. So we had a little bit of an improvement there. Well, actually, a lot of improvement there. The hope is that the charge leak rate through the capacitor, with a new capacitor like this, we're talking very, very low leak rate, can't elevate the voltage on the other side of the capacitor because there's a resistor going to B minus, and it's just draining everything away. As what the heck is that? Oh, you know what this is? I just realized this is the center of a PL259 connector that fell apart on another radio. That's what that is. Okay. Hey, curiosities in my own shop. So I think that was a good thing to do, but it has not solved this this hum we hear. Maybe we should go after that next. Where's this hum coming from? Kind of a higher frequency hum. Volume down, volume up. So it seems to be there all the time. The volume's not having any effect on it. Just on a long shot, I'm going to reverse this plug. Now that should not make any difference because this is not a regular outlet. This is going to a isolation transformer. But sometimes things are easy to do. You know, tests can be very easy to do or inconsequential if you do them. So why not do them just to see once in a while? You'd be surprised by something. Well, how could we even approach this question? Let's switch bands here. Volume's down. Okay, switch bands. The hum situation didn't change at all. So this is clearly happening in the later stages of the radio. Yeah, I'm not going to bother looking for stuff. my. Hey. Oh my. The dirty switch. Okay, we found something here. And if you look at it, it is really a mess. It's really a mess there. So we're going to blast it first with some alcohol. Ooh, should I do this with the radio operating? I've only ever set one radio on fire. Well, maybe two. I think I see another peculiar coil down here, just in behind here. Alcohol everywhere. This is where the fire can start. That sounds pretty consistent now. Okay. I'm quite serious about that. I'm spraying alcohol into the radio. When you throw these switches, sometimes they're breaking B+, there can be a spark. And I did set a radio on fire years ago. Just a little tiny blue flame, no big deal. Poof, was out. Okay. Let's see where we are. Oh, so now the volume is good. Sort of. Much better. Okay. But the buzzy hum has not gone away. Can't quite zero out the volume. Okay. Buzzy hum. What could cause that? Okay, what could cause a buzzy hum? So I usually think these things have to do with the grid. And the first grid I would be thinking about is this one. But I think it's actually more likely this grid here. This is more sensitive. It's more amplification from here over than just through this tube. Something going wrong on the grid here could produce sound out the speaker pretty easily. What could go wrong? So we see the signal coming from the volume control, coming along here, going through this capacitor, and then on up to here. Well, this capacitor could be in trouble. Now let's go back and take a look here. So I see this dotted line. It suggests all these parts are inside of the IF can. The capacitor there, that capacitor, this resistor. Yeah, so that's not helpful if something's going on in here. But I think the first place to go is this capacitor. My thinking here is that if this has developed a high impedance, is that even possible? If it developed a high impedance, then this starts becoming more like an antenna here. This great big resistor is as if it's not even there, 3.3 megohms. So you have an antenna hooked up to the grid. That's how I look at it. If the capacitor is good, then it's kind of grounding out, sort of, through here. That's my theory. It's probably a bunch of hogwash, but I'm going to change this capacitor and we'll see if the hum goes away. Normally this particular capacitor is really easy to find because it comes right off the volume control. So here's the volume control, and there's the center terminal, and there's the capacitor right there. That's the guy. I don't know. I would think if it's somehow sensitive to hum, that just getting near it would increase it. Hey, that does change it. Okay, now do crazy thing. Put my hand on the chassis. Oh, that's a hot spot. Resistor's hot. It's not terribly hot. Hot enough to make me yank my hand away. Put my hand on the chassis. Somewhere. Nice radio. Good radio. That didn't do anything at all. So we'll change that capacitor I'm guessing it won't do anything. And what size was that? Did anybody notice when I had this schematic up? I'm looking now. 0.01. Okay, we'll stick a 0.01 in there. See what happens. Okay, we're ready for another test here. I have the capacitor in. There we go. 10 volts first. We should test this guy too. I don't think this is going to help the radio, by the way. We'll see. That's my guess. Hey, the hum is gone. Oh, that made a pretty big difference. Wow, okay. My theory, thumbs up on it. I was already working on the next theory of where the hum could be coming from. But let's check. We'll do the last thing we'll do is we'll check the capacitor I extracted here. Let's do that. And here it is. Okay, so the name of the game is what happens to the magic eye here. Let's get in a little closer on it. It's hard to see, but there's an open pie at the bottom here. It's a shadow here. Okay, so 50 volts, what do? That thing just popped right open. No, wait a minute, let's try this again. Wow. Okay, so that's behaving quite well. Go up, so 150 volts. Well, at this point, there's enough leaking through to keep the eye closed. So hardly a perfect capacitor, but go back to the 50 volts. Better than many, but bad enough to cause the situation we had there, I would say. So I think maybe the way I described it is true. For some reason, this guy ended up causing that circuit to act like an antenna. Yeah, I would say it's a loss of capacity in here. Why don't we measure the capacitance of this? Now, I could have done it with that machine. We just had it on. But we're going to use a different guy here. So let's try it with this one. So leaky capacitors tend to test high. That's my experience. So they look like they have more capacitance than they really do. Instruments can't. You know, they're not designed to test defective parts, right? Actually, this is designed to test defective parts. Let's see. Let's see what it says. So it says the capacitor is 16 nanofarads. 16 nanofarads would be 0.01. So 0.016. It's supposed to be a 0.01. It's showing closer to a 0.02, and with a 6% V loss, which I don't know what to make of that. So testing high suggests it's leaking. I mean, is the capacitor going to get more and more capacity as it ages? I think that the capacity is very much a physical thing. It has to do with the physical, you know, spacing and type of foil and all that kind of stuff. And that doesn't change. What changes is the moisture level. I think that's really the entire deal. Okay, well, I think I'm done for today. Got rid of the hum. That's good. Replace a tough capacitor. Eliminate a little bit of charge getting onto the grid of the output tube. All good stuff. Okay, we'll just carry on tomorrow. Fantastic. Thanks a lot for watching, and have a great day.